Okay. All right. Yeah. Then, welcome to the afternoon session. My name is Jan Vornberger, and I will be presenting my paper here about market addresses. I didn't know actually that the afternoon session would be recorded on video as well, so I had originally planned to do this in German. But I agree that if we, record it on video, it's probably best to have it in English for a wider audience. The only thing is that my slides will be in German, but yeah, I guess maybe I can provide an English set of slides later, or the audience who isn't German speaking has to do some decrypting to figure out what the slides might say. Okay, so my talk will be, first I'd like to go into the motivation. What was the idea behind market addresses? What problem would I like to solve with it? Then go into the actual solution of market address. How is the mechanism behind it? How does that work? And what kind of advantages and disadvantages does that bring with it? And finally, some comments about the implementation side of things, the code that I've written there, and some experiences I have with it so far. And then close at the end with a short summary. All right, so the motivation. Basically, the general idea behind it for me was to look at how can we do some type of instant transaction with Bitcoin for applications where that is necessary. I mean, we know that because of the way the Bitcoin is designed, we heard of that earlier this morning already. Is the design requires you to wait for a number of confirmations to be really sure that your transaction makes it into the chain permanently. And if you don't wait for that and accept the transaction right away, then you risk being the victim of a double spend. So again, just a quick, we already heard a bit about this morning, but again, to look at a double spend here, the problem we have a person Mallory on the left. He has 1 Bitcoin, and now he can create 2 conflicting transactions. For one side, he says, "Hey, Alice, I'm giving you this Bitcoin," and then he also creates a different transaction that says, "Hey, I'm giving the same Bitcoin to Bob." And obviously, these 2 transactions are in conflict with each other; they cannot both be true. So he sends those transactions out, one to Alice, one to Bob, and at that point they're both happy. They think, "Hey, I got a Bitcoin, great thing." But then when they start talking to each other, you can see it here with question marks on the slide. They kind of, they see something is wrong, and then the rest of the Bitcoin network also isn't really sure what's going on because these 2 transactions are conflicting with each other. But then obviously in the long run, that's one of the great things that Bitcoin brings. This problem will be resolved through the proof of work mechanism. But right now, when I receive the transactions, it's hard to tell which one will actually win out because it depends on many different factors. So this is a risk that we have to deal with if you want to accept fast transactions. So how could we approach this? One idea would be, which actually I think a number of people in the community actually agree with this, to say actually there are more theoretical problems with it, like there are double spend attacks and so on, but they don't really happen in the reality because they're too much work, or they're not really happening. So it's okay to just accept 0 confirmation transactions the way they are, and there's really nothing to be done. So I personally think, and it has already been said this morning, there's actually fairly easy attacks for someone who does it like this. So this is probably not a good idea to do this because you will probably end up being a victim of a double spend attack. So a different approach might be to say, okay, there is some risk, but maybe we can apply some preventive mechanisms to sort of keep the risk a little bit lower. So if you, typically as a standard Bitcoin node, you would have a number of neighbors that you are connected to, and you only hear from them, and they send you some messages, and that's basically all you know. But now you could imagine that maybe you want to get like a bit better understanding of what the Bitcoin network as a whole, sort of what's the state of the Bitcoin network as a whole, and you just open like a huge number of connections to like lots of nodes all over the network to have like a better overview of what is the state of things. And then if I receive a transaction from, let's say, Mallory, then I still can be like, have it a fast transaction if I say, okay, I'm going to give myself like, let's say 5 to 10 seconds to sort of make a risk estimate, and to see, for these 10 seconds, I'm going to watch the whole network closely to see, is there any problematic conflicting transactions that I can see. And if I do see that, then I'm canceling right away. I say here there's something fishy going on. I don't accept this transaction. But if after 10 seconds I don't hear anything problematic, and I see that the transaction that I have received also made it to a number of other partners, so lots of people know about it in the network, then I would say, okay, I think this is probably going to be the transaction that also ends up in the chain. My personal opinion about this is that yes, it does lower the risk of being a victim of double spend attacks, but in my opinion, there are still attacks which then usually involve having a miner as part of the attack who helps to create specific types of blocks, sometimes referred to as a Finney attack. I've written some more about it in my paper. I'm not going to go into details here, but personally, I think that these risks are still too high to really accept it as a merchant who has a number who has high value transactions, for example, where it's not feasible to do this. So I try to look into a third idea, which is basically comes from the observation that a double spending can, of course, only be performed by the owner of the coins, right? So if Mallory sends me a transaction, then only Mallory can create a conflicting Bitcoin transaction, because only Mallory has the private keys to it. So I don't really have to be concerned about sort of any number of attackers, but only have to be concerned that the person that sent me the original transaction might be trying to rip me off by creating a double spend. So the question of the risk of this particular transaction becomes a question of the trustworthiness of the person who's sending me this. And that's sort of the idea where market addresses come in to say, okay, we look at who is sending me these coins, and if I know about them, and if I have some kind of trust relationship with them, and I know, okay, they're probably not going to rip me off, then I accept this transaction. And of course, that's not sort of like a universal solution to the problem, because now I can only do business with people that I have like a pre-existing trust relationship. But at least for those cases where I do have that, I can then be fairly sure and just accept transactions right away without having to worry about whether they're actually going to make it in the chain later. Okay, so that led me to look into market addresses, and sort of the first sort of design decision that you would have to make here is to see, should this figuring out who is sending me the coins, should that happen out of band or in band? So looking at out of band solution, you could imagine that if someone sends me money through the Bitcoin system, that we could also establish an extra communication, a separate communication channel outside the Bitcoin network, some kind of direct IP connection or whatever, where we communicate some extra details about the transaction. And through this connection, the sender could, identify himself, and then I can know, oh, okay, this is Paul, and I know Paul, so that's no problem. And while we have that channel, we can also communicate extra information through it, maybe some details about what is this payment for, and other metadata. And that would be sort of like a payment protocol on top of the Bitcoin system. And personally, I think that's definitely something that in the long term would be needed for Bitcoin to support more sophisticated applications on top of it. But I also think that it's a pretty big undertaking to design such a protocol, to consider all the things that it needs to make possible. Because today Bitcoin payments can work in lots of different settings. I can see an address just on a website. I can scan a QR code and give Bitcoins to someone through that. And if I want to really have a versatile payment protocol, then it would need to support all these different situations. And the hardest problem, of course, is always to find the person to start this channel. Because obviously, if I send Bitcoins to an address, there's no obvious way to find like an IP address or something to the person that belongs to this address. So there's a whole new challenge of having some kind of naming system or some way to open this connection. So I see this more as like a long-term challenge to design such a specification. But for the moment, I have decided to try to do something in band, which might be a little bit more hacky then, but it has a number of other advantages. So this is what I went for, and that's what resulted in marker addresses. So what is the idea behind marker addresses? First of all, if I talk here about transactions, I mean, technically transactions, they have like this whole script system inside of it, which actually allows like a number of fairly complicated different constructs. So I think it's a little bit too confusing to talk about it at that level. But like the standard transactions that are in use today is like best thought of, I think, and also this morning it was discussed that way, to just say you have like a number of addresses which hold a number of coins, and then a transaction just takes coins from different addresses and sends them to a number of other addresses. And that's sort of definitely an abstract way to look at it, which is useful to think about the system. And in the marker address mechanism, the idea is basically to take one Bitcoin address and sort of make it special and make it as an identifier for yourself. So if Paul wants to be identified, Paul picks one of his Bitcoin addresses and says, hey, this is going to be my marker address, and he publishes it somewhere on his website where people can look it up. And then he makes sure that this marker address has like a small number of coins, just some spare change. Here, 0.01 Bitcoin is proposed. And if he now creates a transaction, then he does so normally, picks the number of his addresses where he has coins, and specifies them as inputs to the transaction, but then also takes a little bit of spare change from that marker address and sends it actually right away back, that little spare change. So the balance at the marker address doesn't actually change, but the effect of it is that the transaction now also needs a signature from the marker address, from the private key that belongs to the marker address. So that if I now receive such a transaction, I can actually look at sort of who signed this transaction, and then I see, hey, it was signed by the key that belongs to the marker address of Paul, so I know this transaction comes from Paul. And that's basically just the simple idea behind it, that I just designate some Bitcoin addresses as special marker addresses and publish them beforehand to allow people to sort of put their specific fingerprint on a transaction so that I can easily identify them when I receive the transaction. So doing it that way has actually a few advantages. The first is, as it was said before, is that it's in band. So it's just a normal Bitcoin transaction with like a specific structure, but that means it just works everywhere where Bitcoin works today. I can just, as long as I have the Bitcoin address of the person that I want to send Bitcoins to, it'll work. It doesn't matter whether that person is like behind a firewall or doesn't have like a static IP, or I don't need to like have a way to open that out-of-band communication channel. I can just use the Bitcoin network, and that person will also be connected to the Bitcoin network in some way, so the transaction will reach it. And in that way, it's also backwards compatible to all the existing infrastructure. It can just work over the networks and the and the tools that are in use today. Unfortunately, it also brings a number of disadvantages with it. So the biggest one being the effects on privacy, because of course there's no way for, because all Bitcoin transactions are public, everyone can actually look for the market address of Paul and can figure out which transaction has he marked this way. So not only I know that this transaction comes from Paul, but everyone does. And there's no way to prevent that because of the public nature of the blockchain. And this kind of issue with privacy might cause problems in certain settings. Then another point is it increases the size of the transaction slightly, because you add this extra input from the market address and the extra output from the market address, which actually don't do anything for the value of the transaction. You only did that to have your fingerprint on it. So it's, in the end, like in the long run, it's actually unnecessary data, which now is part of the transaction and ends up in the blockchain where it has to be stored for forever. So that is an unfortunate side effect. And then finally, of course, the bigger issue is that now if you build such a system based on trust, you have, of course, a whole new set of issues to figure out. Who can you actually trust? What do you do if they cheat on you anyway? And how do you find people that you trust, and so on? So that's a whole new set of things to do. Regardless, if I wanted to play around with it a little bit, I did this already July last year. At that point, I was running a website called InstaWallet. I don't know. Someone maybe has in the room here come across it. It's like an online Bitcoin wallet where, so you don't download any software, you just have like a website which you can use to receive and send Bitcoins. It was meant as an easy way for people to get started with Bitcoin. And I implemented this idea, market addresses, back at that point. I called it green addresses as a feature. I implemented it back then, and it was an extra option that you could use on the website. So you could send Bitcoins, and you could say, please identify that this transaction comes from InstaWallet. And the system actually processed 12,000 of these transactions during the time that this feature was active. March this year, I sold the website to Paymium, which is a French company which also deals in, which has projects around Bitcoin, and they have actually changed the back end of InstaWallet. So at the moment, this feature is not available anymore. Another thing is that October last year, Mt. Gox also decided to play around a little bit with this idea. Probably many here are aware of it. Mt. Gox is the largest exchange, Bitcoin exchange, has the largest volume. And to this day, they have an option. If you withdraw your Bitcoins on the site, then you can say where do you want to send your Bitcoins, and you can tick this option, use a green address, which then identifies the transaction that is created as one that comes from Mt. Gox. So you can look at the transaction and know this was sent by Mt. Gox. And then, for example, you can say, hey, I'm going to accept this transaction right away because I know Mt. Gox is like an honest business and they won't do any double spending on me. So that was last year. At that point, I was still calling this green addresses. And then when I became aware of this workshop here, I decided that would be a good opportunity to sort of write this paper and sort of summarize the ideas around it. And for the paper, I called this market addresses. So after finishing the paper, I went back into, because for some time I hadn't really played around with it anymore, but I started again to improve the code a little bit. So you can find some of my patches on my GitHub account. So what I implemented basically for the receiving side is a method called getOrigins. So if you have this patch in your Bitcoin daemon, then you can just use this method getOrigins and give it a transaction ID, and then it will return, and it will just give you all the Bitcoin addresses that were used to fund this transaction. So all the addresses from where coins came for this transaction, and return it as an array here. Origins, you can see in this case, it's just one address that's funded this transaction, And this address is actually the marker address of Mt. Gox, so you know that this transaction came from Mt. Gox. And on the other side, the sending part, this is still a little bit hacky because so far it's only a hard-coded system. So if you have the patch, you actually need to hard-code your marker address that you personally use. And then the code expects that your wallet contains the necessary private key. And if you have that, then all your outgoing transactions will actually be marked this way. And you can see here a transaction that was created this way. So in this case, this one MA was the marker address, and you can see that the transaction was created so that a little bit of spare change comes from that address and was also sent back to it to not reduce the balance at the address. Yeah, so in summary, basically the idea of marker addresses is just a simple mechanism to allow in-band a sender of a Bitcoin transaction, allow him to identify himself to the sender, usually to be used by the sender for fast transactions, so that, you know, if the sender knows, if the receiver knows the sender, then it can, you know, treat the transaction with like a special fast track system or something and just accept it right away. Okay, and then I'm finished with that. Thanks.